Okay, so we're back now, going through the last section of 6.1 to explore a culminating greatest common factor type factoring, which is known as factoring by grouping. Factoring by grouping is going to be an essential type of factoring that will be important to help us, particularly in factoring trinomials that have an a coefficient greater than 1. Now, if you don't know what that means at this time, that's okay. We'll get to that technique. However, this is a video I encourage most students in the class to watch strongly, as most students are usually not comfortable with this type of factoring unless they've been taught this similar technique by another instructor. So let's go ahead and explore what factoring by grouping looks like by looking at a couple questions. So we're looking at question 80 in 6.1, and we have the following four-term polynomial. xy plus xz plus wy plus wz. So we call this factoring by grouping because what we're going to do is we're going to take this polynomial of four terms and we're going to go ahead and split it up into two groups. Notice that I underline the sign of this because this can be important. So we have xy plus xz, and here we have wy plus wz. And I can put the plus sign here. I simply need to acknowledge it, particularly if it is a negative, because that will impact the type of factoring we engage in. So from this work here, I take a look at each group. And what I try to do is identify what is the greatest common factor I can factor from it. So from xy and xz, that greatest common factor is going to be x. That will leave us here with y plus z. In the second binomial factor, I have wy plus wz. Well, from that, I can factor out a plus w. It is important for this type of factoring to acknowledge that this is a plus w, as you'll see why in a little bit. When we factor w out, we'll see we have left here y plus z. So now below we have x times y plus z plus w times y plus z. I'm going to go ahead and write that again, so I just consolidated and make it a little more neater. And when I look at this, just like the problems we looked at in the previous video, we can see that there's going to be a binomial that I can factor out of this, namely y plus z. And when I factor out that binomial, what I'm going to be left with is going to be the quantity of x plus w. And this is why it's really important to retain that plus. So that gets built into the second binomial here. So to tighten this up and bring this together, we have the quantity of y plus z times x plus w. And this will be the factored form of the problem that we have up here. And that is how we use the technique of factoring by grouping. So we split this up into two groups. From the first group, we factor out the greatest common factor. From the second group, we factor out the greatest common factor. When we put these two groups together, we then factor out the greatest common factor, which turns out to be a binomial, and then we come up with our result that we have here. Within the type of factoring by grouping, it will always involve factoring out a greatest common factor from two different binomials, and then factoring out a binomial from what you get as a result of that. So look for this in future questions, and we'll again go forward. Question 82. This is going to be y to the third minus y to the second plus 3y minus 3. So again, this is a polynomial with four terms. We're going to try factoring by grouping. So we're first going to split this up into y to the third minus y squared, and then 3y, or plus 3y, minus 3. So we split it up into two groups. We then try to factor out a greatest common factor out of each of these groups. So for y to the third and y to the second, the greatest common factor is y to the second. So what remains behind? Y to the second times y is y to the third. Y to the second times 1 is y to the second. So we need to keep that 1 there, or put that 1 there. For 3y minus 3, the greatest common factor is going to be plus 3. So here we have 3 times y, giving us 3y. And here we have 3 times, so bring down the minus, 3 times 1, giving us 3. So we have resulting here, and I'll write this down again together more closely. Y squared times y minus 1 plus 3 times y minus 1. And we have this all together now. When we look at what's together here, we see we have a common binomial factor of y minus 1. And when we remove that, we have left y squared plus 3. So that is going to get us the final result of y minus 1 times y squared plus 3. So these are the two binomials we get as a result of factoring what is up here. Let's take a look at just a couple more questions before we go into section 6.2. Let's consider 84. So we now have p to the third plus p to the second minus 3p plus 10. So when you look at this, you have to determine if this is something that can be factored with factoring by grouping. Sometimes you can do it this way and sometimes you can't. So let's take a look at what happens when we split this up. So from the first term we have p to the third plus p to the second. The second term is going to be negative 3p plus 10. What I can factor from this is going to be p to the second. This will be p plus 1. Over here, and this is something you may have to do with factoring by grouping, the only thing I can appear to factor out of this is a negative 1. Now for this one, yes, you do need to put the 1 there, and let's see what happens. And I'm going to go ahead and switch the signs. So let's see, plus 3p minus 10. And let's go ahead and tighten this up. Now, if we take a look at the binomial factors here, we'll see that the binomial factors are not identical. As a result, we cannot use the technique of factoring by grouping to factor this any further. So we cannot apply factoring by grouping. FBG, factoring by grouping. Why can we not? Because the binomial factors that are obtained from this technique are not the same. And there is nothing that we can do to this that will make it so. Therefore, we cannot go forward with this. So an important condition of being able to use factoring by grouping is that you have to obtain identical binomial factors in order to go forward with it. So this question serves as a nice example to illustrate that important point. Let's go ahead with a few more questions before we go into section 6.2. Let's go to question 86. This is going to be t to the third plus 6t squared minus 2t minus 12. Again, I'm going to go ahead. I'm going to just split these up. I'm going to write this as t to the third plus 6t squared. Then that minus 2t minus 12. Well, from t to the third and 6t squared, the greatest common factor I can factor out of this is t squared. T to the second times t will give me t to the third. And then t to the second times 6 will give me 6t squared. From the second one, the greatest common factor I need to factor for this has to be a negative 2. Now, if you're getting lost in some of the types of factoring we're applying here, please go back to some of the earlier videos we have on factoring from section 6.1. It is important that you understand these building blocks because these get more complex as we go into greater forms of factoring. So, negative 2 times t will give us negative 2t. Negative 2 times positive 6 will give us negative 12. And remember, when the first term of a binomial is negative, we must factor the negative out. And because both of the terms in the original binomial were negative, when we factor that negative out, both of the terms will end up being positive. If you do not understand this concept or this is unclear, please refer to the video on factoring out negatives from an earlier session. Now that we have this, let's tighten it up. T to the second times t plus 6 minus 2 times t plus 6. From this, I can now factor out the common binomial of t plus 6. And in doing so, this will leave me with t squared minus 2. So let's tighten that up and we'll write this as t plus 6 times t squared minus 2. Once in a while you will get something that can factor from here, but this is not such an example as 2 is not a perfect square. So this is going to be the answer in its final form. Let's take a look at another problem and let's see what we generate here. This is going to be question 88. We have y to the fourth minus y to the third minus y plus y to the second. So one technique that may help to clean this up a little bit, you'll see that if we split this up, let's go ahead and do that first. I can write this as y to the fourth minus y to the third. Well, I can rewrite this so I have like the plus y squared, the negative y squared. So I'm going to go write this as y squared minus y. One reason is we have these in descending order, y to the fourth and y to the third. So good to have these in descending order. And by descending order, I mean that the exponents go from 4 to 3, and this goes from 2 to 1. The other reason is by putting these in this order so that this y squared here is positive, it'll save us the trouble of having to factor out a negative and possibly making a mistake or a sign error. Now that we have these separated, let's factor out the greatest common factor. This is going to be y to the third. Y to the third times y will be y to the fourth. Y to the third minus y to the third times 1 will be y to the third. Now, since we've done this a few times, I should probably give you a heads up on this. If you're doing factoring by grouping and you're getting y minus 1 over here, you should look to get y minus 1 over here too, if the technique's going to work. So for y squared and y, we're going to look to factor out a plus y. Y times y will give us y squared. Y times 1 will give us y. And lo and behold, yes, we do in fact have y minus 1. So let's go ahead and rewrite this below. Just moving it over a little bit, so plus y times y minus 1. So what can I factor out of this? The binomial y minus 1. And when I do that, I'm left with y to the third plus y. Now, here's another little thing here. When you end up with a factor like this, so you have like y to the y minus 1 times y to the third minus y. I should still be able to take out another y here. So from y minus 1, I can still factor out, let's see, from this I can factor out a y, and I'll make it y squared plus 1. And I'll tell you why I got this answer. The one thing I should have done with this problem originally First thing, let's go ahead and put this in order. So the first thing I should have done with this problem is what I always tell you to do, is to look for the greatest common factor. So I'm going to go ahead and I'm going to do that now. So the greatest common factor of this is going to be y. And what that's now going to give us is going to give us y to the third minus y to the second plus y minus 1. So when we get this result, let's see what happens, because this will be kind of interesting. And there's a technique to this you need to be familiar with. And I'll highlight that in a moment. So I'm going to take the polynomial of 4 terms here, and again we're going to split this up. But we're going to keep track of the y that's on the outside. So we have y times y to the third minus y squared plus y minus 1. From y to the third minus y squared, I can factor out, in fact, let me put this in brackets here. I can factor out y to the second times y minus 1. But if we look at this here, from plus y minus 1, there is nothing I can factor out. Nothing except plus 1. So if you can factor nothing else out, you can always factor out a plus 1. Because by factoring out plus 1, what do you have left? You still have y minus 1. So you haven't changed that at all, but by factoring out the plus 1, or just putting a plus 1 there, you still retain the y minus 1 that you have here, and you have the y minus 1 here now. So let's tighten up what we have here a little bit. So this is y squared times y minus 1 plus 1 times y minus 1. From this, what can we factor out of this? We can factor out y minus 1. When we do so, we have y squared plus 1 left. So now we can write this as y times y minus 1 times y squared plus 1. So we still get the same answer, just instead of the y being in the middle here, it's at the end. But we still have y times y minus 1 times y squared plus 1. So sometimes there may be multiple techniques to this. However, I would really strongly encourage you to always try to factor out the greatest common factor first. That ends our lesson on factoring by grouping. We would take a look at this in more complex terms when we learn how to factor out trinomials.